Welcome to the 11th episode of our video tutorial series. In this episode, we'll explore how to integrate our Crossroad Generator with the powerful Procedural Content Generation framework in Unreal Engine 5.5. We'll walk you through the process of combining these tools to quickly and efficiently populate your levels with foliage or any custom assets, dramatically streamlining your level building workflow. By leveraging the procedural power of PCG, you'll be able to create rich, diverse environments with minimal effort, giving each project a unique, dynamic aesthetic. We'll also demonstrate how effortlessly you can bring in high-quality assets from the Quixel Megascan Library, taking your scenes from basic layouts to cinematic quality visuals in just a few minutes. Let's dive in and see how you can elevate your world building with this powerful integration. Alright, let's kick things off with a fresh new level. First, head over to your project settings. Scroll down and make sure virtual texture support is enabled. This is super important to make sure the Crossroad Generator works as expected. Next, jump into the Plugins menu and enable the Geometry Script plugin. We'll need this for some of the procedural stuff we're about to set up. While you're there, also turn on the Procedural Content Generation framework plugin. That's the main framework we'll be using for this whole process. Now let's clean up our default level. Go ahead and delete the floor. Instead, we'll replace it with a basic landscape. Just create a simple one, nothing fancy for now. You can apply a basic material to make it look a bit more interesting. In this case, I'm going with a simple rocky soil material for a more natural vibe. Once that's in place, open up the Crossroad Generator folder and drag the Crossroad Generator blueprint straight into the level. After that, spawn in all the roads using the generator, and feel free to tweak the shapes a bit to make your layout more unique. When you're happy with how the roads look, create a new folder, let's call it PCG, and inside that, create a new PCG graph. Name it something like PCG_foliage or whatever fits your naming convention. Drag and drop the graph into your level and adjust its transform so the PCG gizmo fully covers the road system. Once you've got the PCG gizmo in place and adjusted to fit your road layout, double-click it to open up the graph. Now we can start adding some nodes to build out the logic. First up, let's bring in the Get Landscape Data node. This pulls in the terrain for sampling. Since we want to scatter sample points across the surface, let's drop in a Surface Sampler node right after that. Set points per meter to 2, and the point extents to 15. Make sure to enable debug so we can see where the points are being scattered across the landscape. You'll notice that points are showing up over roads and intersections, but we want to exclude those from the sampling. To handle that, let's add a Get Actor Data node. We'll use this to grab specific actors from the level, like our crossroads. Make sure to set the filter to all world actors. This tells the PCG system to look through all actors within the gizmo's bounds, and then filter out just the ones that match the tag you specify. Each actor should have a tag. In our case, intersections are tagged as intersection, and roads are tagged road. Let's start with intersections. Set the selection tag in the Get Actor Data node to intersection. This tells PCG exactly what actors we want to filter out. Now add a volume sampler and connect it to the actor data. Set the voxel size to 12. Turn on debug for this node too, and now in the editor you should see a voxel grid representing the intersections. Next, let's exclude those points using a difference node. Plug the volume sampler into the difference node and set it to binary mode. That will completely cut out any overlapping points from the landscape sampling. Now let's do the same thing for roads. Add another getActorData node, set the filter to all world actors, and apply the tag road. But roads are splines, so we'll use a spline sampler here instead of a volume. Connect the getActorData to a spline sampler and set subdivisions per segment to 10. Switch the scale method to absolute, and press the D key on your keyboard to toggle debugging. That'll let us clearly visualize how the points are being distributed along the road splines. Also, make sure to enable Select Multiple in the actor selection settings. This ensures that all spline-based roads inside the PCG gizmo are included in the filter, not just one. To define the width of the roads, we'll use a bound modifier node. In the bound modifier settings, make sure to set the mode to include. This tells the PCG system to treat anything inside the bounds as part of the exclusion zone. Set the minimum bound to -250 and the maximum to 250. That gives us a 500 unit wide exclusion zone around each road spline. Don't forget to turn on debug again. This lets you visually check the road bounds right in the viewport. Now plug the bound modifier into the difference node, and just like that, the PCG graph will exclude all roads from the point distribution. And here's the cool part, this setup is completely dynamic. If you update the layout, say you swap a 2-lane crossroad for a 4-lane one and hit refresh on the attached roads, the exclusion zones will automatically update to reflect the new geometry. If you still see points overlapping the wider roads, just tweak the bounds in the bound modifier to better match the new dimensions. Now, what if you've got mixed road types, like a 4-lane road connecting to a 2-lane one at the same intersection? To help PCG recognize which roads are different, we can assign unique tags to each road type. For example, tag the 2-lane roads with something like road_2, so the PCG system can tell them apart. Back in the PCG graph, just duplicate your road filtering setup. Copy the nodes, update the tag in the getActorData node to road_2, and connect the rest to the same difference node. This way, your PCG logic can handle different road sizes independently, and your point distribution will stay nice and clean. Alright, once we're happy with how the points are distributed on the landscape, let's spice things up a bit by adding some random variation to make everything look more organic. Jump back into the PCG graph, and right after the difference node, add a transform points node. This is where we can randomize each point's position, rotation, and scale. Let's rotate the points randomly by setting the maximum rotation to 360 degrees, and scale them up randomly by setting max scale to 2. Now you'll see the points are scattered with different sizes and angles, much more natural. Next, let's replace these points with some actual mesh instances. We'll start by scattering grass across the landscape. Add a static mesh spawner node and create 2 entries in the mesh array. We'll use grass clumps from the Megascans library. Just drag and drop your chosen grass meshes into those array slots. Now when we head back to the editor, you'll see the points replaced with your grass meshes. Go ahead and turn off debug on the transform points node to clean up the view. Nice! Grass is now scattered across your landscape. Let's keep going and make this scene more visually interesting by adding sidewalks, road markings, traffic lights, and even curbs to the roads. As you'll notice, the grass might be overlapping with sidewalks and roads, not ideal. To fix that, jump back to the bound modifier connected to your road actor data, and tweak the values until the grass gets pushed away from those areas. You can even fine-tune each bound modifier per road type to keep everything clean and precise. Once it looks good, let's organize our graph. Select all the grass nodes and group them using a comment box. Label it something like grass so we know exactly what that chunk of nodes is doing. Now let's reuse that setup for something new: scattering trees. Copy the grass node group, paste it below, and rename it to trees. We'll tweak a few values so the trees don't overwhelm the scene. Change the surface sampler to use fewer points, for example, set points per meter to 0.1 and increase point extents to 50. That way, trees are more spaced out than the grass. Also adjust the bound modifiers so trees don't spawn too close to roads. To help with tree density control, add a self-pruning node. This will reduce overcrowding by culling some of the nearby points. Next, go into the static mesh spawner node and swap the grass meshes with a few tree assets, again from the Megascans library or any assets you prefer. Once that's done, you'll see trees scattered naturally across the terrain. Go ahead and disable debugging on the self-pruning node for clarity. Now, let's move on to scattering buildings. For this part, we're using our custom building generator tool. It's perfect for quickly creating building variations for testing, prototyping, or populating city scenes. You can check it out on the Fab Marketplace, the link's down in the description. Place a building in your scene and adjust a few of its visual settings to get the look you want. To hook it into PCG, we first need to tag the building's blueprint with something recognizable, for example, building. Now jump back into the PCG graph and add a getActorData node. Set the filter to all world actors and assign the tag building. Make sure Select Multiple is checked in case you add more buildings later. Next, add a bound modifier to define the exclusion zone around buildings and enable debug to visualize it. To stop grass and trees from spawning underneath buildings, we need to exclude points in that area. Add a projection node to project the sample points back onto the terrain, and plug everything into a new difference node. When you hook that into the grass setup, you'll see the grass automatically gets removed from under the building. Repeat the same steps for the tree group, just copy over the nodes you created for grass, plug them into the tree group, and you're set. Once you adjust the bound modifier for trees, PCG dynamically updates all the point distributions. Trees, grass, everything adjusts in real time. You can keep repeating this workflow to add as many buildings, props, or scatter types as you need, whether it's trees, rocks, street elements, or entire city blocks. Everything stays fully procedural and completely under your control through PCG, so you can quickly make changes, test different setups, or scale your environment without manually placing every asset. This flexibility is what makes PCG such a powerful tool for world building in Unreal Engine. Now let's scale things up a bit to demonstrate how this setup works on a more complex road system. For this example, we've created a larger road network, complete with multiple crossroads, road types, and even a bridge, so we can see how our PCG setup adapts to a more realistic environment. We'll use the exact same PCG workflow we set up earlier, just applied at a larger scale. First, generate the PCG on the landscape and make sure the PCG gizmo covers the entire road system. This ensures foliage and any other scattered assets will be distributed across the full terrain. If we take a closer look, you'll notice everything is working smoothly. For example, the trees are not overlapping the bridge. That's because we tagged the bridge as a separate actor and excluded it from the distribution using a volume sampler connected to a difference node, just like we did with the roads and intersections. This same approach can be reused for any kind of prop or asset you want to exclude from scattering. Just tag it and filter it through your PCG graph. We've also created a separate PCG graph just for building placement, so foliage and structures don't interfere with each other. In an upcoming tutorial, we'll go in-depth on how to combine PCG with our building generator tool, showing how to procedurally place buildings while keeping full control over how they interact with the rest of your scene. That video's coming soon, so stay tuned. Thank you for watching this 11th episode video tutorial. To delve deeper into its capabilities, we encourage you to explore all the tutorials available on our YouTube channel. If you're seeking to elevate your environment and create stunning scenes, the Crossroad Generator for Unreal Engine is an indispensable tool. You can find it on the Fab Marketplace, and the link is available in the video description. Thank you for watching, and don't forget to render your tale with us.